Welcome to lesson 123, the greatest common factor. Today's objectives: I will be able to find the greatest common factor of a set of numbers, and I will be able to use the greatest common factor to solve real-world problems. Right, again, vocabulary. So we have to think of the word greatest. Greatest means the biggest or largest. Common means the same. And factor is a whole number that can divide another number without a remainder. So we're trying to find the biggest number that can divide another number without a remainder that two numbers have that is the same. To make that a little bit easier, we define the GCF, or greatest common factor, as the largest factor that two or more numbers have that is the same. Right, this is a little different from the LCM, where we were looking for the smallest common multiple. Now we're looking for the greatest common factor. Remember, factors are the numbers that make up a number or that will divide a number evenly, and multiples are numbers that we get when we multiply. All right, so the first way that we can use to find the greatest common factor of any number is to list all of the factors. So if we're trying to find the GCF of 16 and 24, we can first list the factors. So the factors of 16 are 1, 2, 4, 8, and 16. Right, and don't forget that we have to have the parentheses around those. And then the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Once you've listed all the factors, you want to find the biggest one that they have in common. So start with the biggest number of the smallest factor. So 16 is smaller than 24, so we're going to start with 16's largest factor, which would be 16. Okay, and it does not have that in common. However, it does have 8 in common with 24. So the largest common factor, the GCF, of 16 and 24 is 8. And we start with the largest factor of the smaller number because this smaller number can't have a factor of 24 or can't have a factor of the larger number because you can't divide a smaller number by a larger number evenly. Okay, so now I would like you to try on your own. I want you to list the factors of 18 and 36, and I want you to find the greatest common factor. Using this method means that you need to be very good at knowing all of your factors and finding all of the factors of a number. So this might not be a method that a lot of you choose, and that is okay. But please take a moment now to pause and try this problem on your own. When you come back, we'll go over your answer. All right, so you should have found 1, 2, 3, 6, 9, and 18 as your factors of 18. And then 1, 2, 3, 4, 6, 8, 12, 18, and 36 as your factors for 36. Again, start with the biggest factor of the smaller number, which is in this case 18, and they actually do have 18 in common. So the largest factor, the GCF, for these two numbers is 18. Okay, the other method that you can use is the ladder method. Now, we used the ladder method when we talked about finding the LCM, and when we found the LCM, we could only put in two numbers at a time. With the GCF, you can put in all of your numbers at once. Okay, but you have to begin with a prime factor that divides into each number. So what goes into 12, 18, and 60? In this case, it would be 2. 12 divided by 2 is 6. 18 divided by 2 is 9. 60 divided by 2 is 30. Another prime factor, so we continue this just like we did before. We can use 2. 6 divided by 2 is 3. I'm sorry, not 2. We can use 3. And then we would get 2. Sorry for the confusion. 9 divided by 3 would be 3. And 30 divided by 3 would be 10. Now, the only factor that these numbers have in common is 1. So now what we're going to do is we're going to multiply these. Okay, and we always know we can eliminate the 1 since it's going to give us the same number. And we take 2 times 3, which will give us 6. So the greatest common factor of 12, 18, and 60 is 6. But the important thing here is these have to be prime. These outside numbers that you divide by have to be prime. If they're not prime, you're going to come up with an incorrect answer. All right, so I would like you to try on your own. I want you to find the GCF of 16, 24, and 32. When you come back, we'll go over your answer. All right, so since they're all even, I like to just start with 2, make it easy on myself. 16 divided by 2 is 8. 24 divided by 2 is 12. 32 divided by 2 is 16. Each of these can be divided by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. 16 divided by 2 is 8. All of these can be divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And again, they have the GCF of 1. Okay, so now we get 2 times 2 times 2, which in this case, 2 times 2. Now, a lot of us like to put 6. Remember, this is multiplication. 2 times 2 is 4. Times 2 would then be 8. So the GCF of 16, 24, and 32 is 8. Right, so when would we use something like this? So this would be a situation where using the greatest common factor would help us figure out how to solve Kim's problem. And Kim's problem is that she's making floral arrangements. She has 16 red roses, 20 pink roses, and each arrangement must have the same amount of pink roses, and each arrangement must also have the same amount of red roses. So what that means is if there are 5 red roses in this arrangement, there have to be 5 red roses in this arrangement. That's what that's telling you. Okay? So there could be 5 red roses and 4 pink roses, but that means that there has to be 5 and 4, 5 and 4, 5 and 4. That doesn't have to be 5 pink and 5 red. It has to just be the same amount of each color in each arrangement. Okay, so what is the greatest amount of arrangements that Kim can make if she uses all of the flowers? So all of this is actually really important information to us. And when we see the greatest, that kind of gives us the implication that we should be finding the greatest number of something, so we're probably going to look for the greatest common factor. And since we're dividing these roses into different groups, we would have to make the connection that dividing the roses into different groups means we're looking for factors, because factors are what can divide our numbers evenly or without a remainder. So in this case, I have 20 roses and I have 16 roses. So I'm going to use the ladder method just to get some more practice with it. So I have 20 and 16, and I can divide both of those by 2. 20 divided by 2 is 10. 16 divided by 2 is 8. I can divide them by 2 again. 10 divided by 2 is 5. 8 divided by 2 is 4. Okay, so I finally get down to that factor of 1. So I'm going to multiply these, and I know that 2 times 2 gives me 4. So the greatest common factor here is 4. But that's not where we stop. The greatest common factor is now going to help us decide how many of each of these I'm going to put in a group. Okay, so in this case, this is my answer because it says what is the greatest amount of arrangements that Kim can make if she uses all of the flowers. So what this shows us is if she makes 4 arrangements, that's the most arrangements that she can make with using all the flowers, because both 20 and 16 can be divided by 4. So what this means is if I take 20 and divide it by 4, I get 5. So I'll get 5 red roses in 4 groups. And we're just going to pretend that these dots are roses. So 5, 10, 15, 20. And then each group will also have, oh, and I apologize. That's actually, we have 20 pink roses. So I will have 5 pink roses in each group. And that allowed me to use all of the 20 roses. And now, if I divide 16 by 4, that tells me that each group will have 4 red roses. And then I will have used all of my pink roses and all of my red roses. So the answer in this case is 4. Now, if the question asked what would the arrangements look like, you would have to tell me that each arrangement would have 5 pink roses and 4 red roses. But in this case, our answer would be the greatest number of arrangements, because we want to use complete sentences, Kim can make is 4. All right, so on Edmodo tonight, this is the problem that I'm going to give you in your video. There will also be a couple other problems on your quiz, but I want you to try this problem on your own. So Kiara baked 30 oatmeal cookies and 40 chocolate chip cookies to package in plastic containers for her friends at school. She wants to divide the cookies into identical containers so that each container has the same number of each kind of cookie. If she wants each container to have the greatest number of cookies possible, how many plastic containers does she need? So I want you to remember the question is, how many plastic containers does she need? All right, so the question is she looking for the greatest common factor here, or is she looking for how to split up her cookies? I want you to choose that, and then you can show me what you choose as the right answer on Edmodo when you take your quiz. As always, if you have any questions, please make sure to post them on Edmodo so we can go over them in class tomorrow.